Hey guys, in this video I'll be showing you how to use the voltage divider rule and why we use it. When we look at what the voltage divider rule is used for, we say that it is used to calculate the voltage drop across each resistor in any DC circuit. Although we can also use it for AC circuits, in this video we'll be looking just at DC to keep it simple. The equation used for the voltage divider rule is the product of the source voltage and the resistor we want to calculate the voltage drop for, divided by the total resistance. Knowing the equation is good and all, but how is this equation derived? Using Ohm's law, we can create an expression for current using the source voltage and total resistance. Since the current is constant in a series circuit, we can substitute this into Ohm's law again, but for a single component this time. This gives us the voltage drop across resistor 1 equals to the product of the source voltage and the single resistor value divided by the total resistance, just like we mentioned before. So as we move across to an example, we need to look at what we've got. We want to calculate the voltage drop across both resistors. We're given the source voltage and the values of both resistors. We'll put the voltage divider rule in the top corner for reference. Next we need to calculate the total resistance, and in a series circuit, it's simply the sum of all resistors. We can see that we have resistors of 6 ohms and 2 ohms. So the total resistance is 8 ohms. Now calculating the voltage drop across resistor 1, we substitute our known values in to get us 10 times 6 divided by 8. 10 being our source voltage, 8 being our resistance of resistor 1, and 8 being our total resistance. Putting this into our calculator, we get 7.5 volts. Doing the same for resistor 2, we can substitute in our values to get 10 times 2, the value for resistor 2, and then divide this by 8. Calculating this, we get 2.5 volts. Now to make sure our answers are correct, we use Kirchhoff's voltage law, where the algebraic sum of all the voltage drops are equal to 0. Looking at the polarity of all components, we can see that the resistors are opposing the source, meaning they will be negative values using KVL. So we let 0 equal to 10, minus our two calculations, 7.5 and 2.5. This equals to 0 as we expected, meaning our values are correct.